Hello everyone, welcome to my class. In this video, I will be determining density of the regular shaped object, irregular shaped object, and water. So first of all, what is density? Density is the amount of matter per given volume. It is the property of substances. It tells us how mass is concentrated. So to determine the density, we need to know the mass of the object and then volume of the object. So mass of the object we will be measuring by balance, and the volume of the object for the regular shape we will be using ruler to determine it, and for the volume of irregular shaped object we will be using cylinder. So I'll show how to use it later. Now what is volume? Volume is for the regular shaped object, the height times width times length, yeah, height times width times and length. So I'll be using this block to make the measurement more precise. So the width of the object is 2 centimeters, and the height of the object is 2 centimeters, and the length of the object is 2 centimeters. So height times length times width, 2 times 2 times 2 will be 8 centimeter cube. So the unit of the volume is centimeter cube. Let us measure the mass of the aluminium block. First, let's switch on the balance and make sure it is 0 still. Yeah, so it is mass is 21.5. So we have now we know the mass and we know the volume of this block. The mass is 21.5 grams over volume. Volume is the 8 centimeter cube. So density of the aluminium is here 2.68 gram per centimeter cube. All right, now let's determine the density of irregular shaped object. To determine the density, we need to measure the mass first by balance. It's 0 now, and the mass of the rock is here 15.8 grams. 15.8 grams. So now I need to measure the volume. So how do I measure the volume of irregular shaped object? We have a technique called displacement of volume. We measure the volume of irregular shaped object by the help of measuring cylinder. In the measuring cylinder, I have 200 milliliter of water. Sorry, 210 milliliter of water. How do I read this? I need to read always from the bottom of meniscus. On the surface of water, you will see the meniscus. So you need to read the value from the measuring cylinder from the bottom of meniscus in your eye level. Yeah, in your eye level, which is 210 milliliter, which equal to the 210 centimeter cube. All right. So first volume is 210 milliliter. So after I put the rock, I will check the final volume. So later on I can see the displacement. So carefully put the rocks or hard objects to avoid splash or breaking the glass. All right. Now the final volume is 210. So here we have 5 lines between 210 to 220. So each line represents 2 milliliter. 1, 2, 3, 3 lines rise it. So the water rise above the 210. 3 lines, each line is 2 milliliter. So the volume of this irregular shaped object is 6 milliliter. How do I know this? So this is the technique. Final volume minus the first initial volume. Yeah, final volume is 210 16, the first volume was 210 milliliters. So 216 minus 210 will be 6 milliliters. So volume of the rock is 6 milliliters. The mass was the 15.8 grams. So 15.8 gram over 6 milliliter will be 2.62 gram per centimeter cube. Yeah. So density of the rock will be 2.62 gram per centimeter cube. All right. Now let's determine the density of liquid. To determine the density of liquid, again, we need to know the mass of liquid and the volume of the liquid. To measure the mass of liquid, I will use the balance. To start the measurement, I need to make the balance 0. Yeah, so I need to ignore the mass of the cylinder. So it is 0 now. And I'll put 100 milliliter of water in it, and so I can measure the volume of still 0. I'll put 100 milliliter of water into the empty cylinder, and I'll read the mass of the liquid in the balance, and volume of the liquid I can read from the cylinder. Later on I can do calculation. All right. Put carefully, don't splash water around, so you won't destroy your balance. Yeah. Well, this is a little bit less than 100. A little bit more. All right. Yeah. Again, you need to read in the eye level and look at the bottom of meniscus. It is 100 milliliter, exactly 100 milliliter is the volume. And let me check the mass. Mass is 98.8. So the mass is 98.8 over a volume is 100 milliliter, so it's gonna be 0.98. Yeah, 0.98 gram per centimeter cube. Okay, here we have another way of using the volume displacement technique to measure the volume of irregular shaped object. I have the same rock. So I have a cup here, exactly aligned with the hole. Inside there is water, exactly aligned with the hole. So if I put anything else, the water will overflow. Yeah, and I have the cylinder, which can just adjust here. Can fit here. Okay. When I put the rock, water will be displaced. Yeah, displaced water will flow to the cylinder. So the amount of displaced water, the volume of displaced water, will be equal to exactly the volume of the irregular shaped object. So again, carefully put it to avoid the splash. Okay, so let us wait until all excess water goes to the cylinder. Okay, so water rise and excess water went to the cylinder. So let us check the volume of displaced water. So we have 20 milliliter here, and this is 10, and you need to look in the eye level, and you must check in the, you must read the value in the bottom of meniscus. So here we have 10, 1, 2, 3, 4, 5. So 1 line, 2 line, 3 lines. So again, bottom of meniscus is at the 3rd line. Each line is 2 milliliter. So the volume of irregular shaped object, which is the same rock, is again 6 milliliter. So this is another way of using volume displacement technique to measure the volume of irregular shaped objects. So this is all for this video. I'll see you in the next video. Thanks for watching.